Hello, everyone. Wherever you're connecting it from, my greetings to you. Thank you for joining us this afternoon. We are going out from Toronto, and today is joining me Efrain Ugarte, a senior geologist with extensive experience in resource estimation. So he's going to share with us his experience about doing resource estimation. And please, we welcome Efrain. Hello, Efrain.
Thank you, Alan.
Okay, thanks.
Thank you for having me in your channel. I'm really pleased to share my knowledge today. And a part of my knowledge, it's difficult to compress this kind of topic in 30 minutes, but I will try.
Yeah, you can talk more than 30 minutes. I mean, the important thing is that you share your experience.
Sure.
And thank you.
Okay. Good afternoon, everyone. So today, while I was thinking this topic, it's when I start gathering all this information to present to you all, I realized that this is really a huge topic. That's probably is that, as I said, is a tip of the iceberg for some people. I understand. I have in the audience people from different knowledge of geostats and resource estimation. I will try to have a very general language to explain all my ideas, and I hope this information will be very helpful for you. In as a goal, my goal is to share and keep with this very nice, how to say, purpose of Alan to share information among all professionals in the mining industry. Okay, the content of my presentation will be, as you can read now. I want to talk about a very brief background about the history and geostatistics. Probably most of you know about geostatistics and history, but I want to be very quick for somebody who want to review it. And I'm going to talk about the estimation workflow, a general also estimation, mineral estimation especially. It has a lot of steps I have to follow. It's a kind of guideline that most of the professionals in this field agree with. So I will show you very generally this workflow, and also I'm gonna focus my presentation in the tips and some advices I can tell based on my experience and my knowledge as a resource estimation geologist. So the topic will be, how to use or how are the most important advices when you perform the exploratory data analysis, the domain definition, and going to talk about some advices about capping, compositing. I briefly explain the clustering process, how is this important, and also how to assess the spatial continuity, which is also called biography, and Q&A or Q&A analysis for previous 2D estimation or ordinary Kriging, and some tips about validation and classification. And finally, I'm going to talk about very briefly too all the things I talk and probably some advices for the future. Okay, talking about the background, it's important to do some clarification before I start. I really don't pretend to teach a class of geostats in this time, but it's just an introduction, so it's very summarizing different ideas. So I assume the general knowledge people about this topic, and also it's based on my experience. I know probably some of you will have more other tips that in one moment you can also share with us. But in this case, I'm gonna share this with you all. But for that, I'm gonna start with a story of geostats, how this field was appear, or how this was developed. This started since the 15th century. As you can read here, this scientists and the theory of probability. But more recently, the very well-known scientist is Dr. Kriging and Matteron, who were, I would say, the people who use geostat for real applications. When I say real application, I mean that in the mining industry, and from that time it started to become more important in other fields. So I would say the geostatistics has about 50 or more years of life with this name. And also we know that the first students from Matteron were Jornal and David. They moved to the US and Canada, and they also they were trying to keep working in the development of this field. I also know that Dr. Kriging also has led a lot of students in South Africa and also in other parts of the planet, in France. And I know recognized people are working on that. Okay, before we start with geostat, it's a very brief review. We have to understand what is the difference between statistics and geostatistics. In reality, many people can say, what is the difference, but they are interconnected. I would say the basis of geostatistics is statistics. In general terms, the geostatistics is a toolkit or applied statistics using geological principle. This is the simple way to explain about geostatistics, how is it related with the geological context of data, a special relationship we're gonna discuss today. And also, it's important to see what is geostatistics, or for what is useful geostatistics. As I mentioned, it's useful for nowadays. They're using in different industry. So, but in general, it's useful for putting the geology into numbers, and also for making different sort of estimations. And nowadays, it's becoming more important with the power of computational things, the quantifying risks or quantifies uncertainty. This is one of the main areas that geostatistics is growing nowadays. But what is not geostatistics? Some people can say, okay, geostatistics is, can be work for some people. Probably it's a black box. No, geostatistics is not a black box. Doesn't work as a black box. And also, geostatistics doesn't replace any type of common sense, or I want to talk about different aspects that are fundamental, but geostatistics doesn't solve all the problems. You have to make, or you have to have a common sense to doing things. So by itself, geostatistics doesn't replace that. And also, it's not a tool that will make you save time and also make the modeling process any easier. That's the things we have to keep in mind when we're gonna enter in this field, or you have a misunderstanding about this field. Okay, why it's important? It's important for, as I mentioned, among different techniques and methods for estimation. We know there are several traditional, one of these inverse distance and error, many traditional type of estimation, but it's proof that the estimation or the spatial distribution, it's more reliable when using geostatistics. It's also controllable degrees. You can have a control of the relationship, spatial relationship of the variables. It's important. And also, as I mentioned, also for risk analysis assessment, which is another topic that I won't talk too much about, that is using some methods for simulation, stochastics, tools for doing and to manage risk and measure uncertainty. Okay, this is the brief introduction to Geostat. Probably some of you now already know that, but it was important for people who really don't know about this topic. Okay, talking about how is the flow work or resource estimation. In general terms, this, as you can see in the picture, start with the data acquisition, which is the basis, I would say, one of the fundamentals or one of the essential things, not the only one, but one of the essential things that the resource estimation need to rely on. This data acquisition goes to the geological modeling, and this goes to a geostatistical model, which is related, basically putting the geology and transforming this in numerical values. And finally, this is going to be applied in mine planning or other mining applications. And also, this is a kind of iterative in mines or deposits that are beginning. They goes to again to data acquisition, and it's a kind of iterative process. In general terms, this could be the cycle of mineral estimation, which means the estimation resource estimation process doesn't finish, doesn't have an end, because all deposits are constantly adding information. So, which means these pictures explain those. This is a kind of summary. I took this from Snowden resource estimation class, but it's also a kind of guideline for the resource estimation process, which is including the different steps that in practice is applicable, that all the professionals agree with. So you see, this is a kind of guideline you will follow when you do resource estimation using geostatistical tools. And also this can be customized if you want to use non-statistical methods for estimation. But in general terms, this is, as you can notice, we start with the information or the data, as mentioned, which is the first area, the first part, that begins with the planification of the design of the drilling program, that they comes to the geological interpretation. You see in the blue ones, I highlighted the blue ones, which is related with the use of statistical and geostatistical tools in the estimation. So means that I want to talk about these points very briefly in the following slides, and it's not being, it's going, I mean, it will not be time to explain everything, but I will explain these blue things in general terms. That will be very helpful for you, and also follow these. This is practically a guideline. I took this, as I mentioned, with Snowden. They made it. Okay, again, as one essential thing, the data. I think everyone will agree with me that data is one of the essential things, probably the most essential thing, besides the other things I'm going to talk later. You saw this graph before, I believe, so it's very popular. It's not only for resource estimation, it's for everything. You have, if your data is not good, so the results will not be good. So geostatistical tools doesn't have a magic word that will transform bad data in the good estimation. which is very important. I put this, it's important to talk about this. I cannot speak about the statistics or estimation that I don't talk about data. Data is the basis of all the, so data also at the same time is a kind of the key assets of any company. Any company spend millions of dollars, a lot of money, drilling, sampling, hiring qualified people to get data. So that's why it's important to talk about this thing in terms of geological estimation and also statistics applications. Okay, starting with the tips here. So I list many things. I probably will read some of them and explain a little bit about what I meant. It's one of these things is, you know, we need to, or we should store this standard database. I mean, have a standard database for our assets, which is the data, right? Because I talk about this thing because some companies, they keep, for example, there is some very nice software, for example, Excel, or probably other similar Google Sheets, etc. They keep data or important, expensive data, and they keep in those things. That I think is I think advisable to keep a database, standard database, base probably SQL or acquire. SQL is the engine, but there is some based on SQL. Keep a database for the data. You know, this is gonna be very good for you if instead use keeping your data in Excel or Google Sheet, whatever. So this is the first thing you should do with data, and also try to transform, because I remember 10 years ago, or I started as an exploration geologist, and also I went to everything were made in paper at that time. I talk about 10 years ago, but nowadays, since the technology allow you to record things digitally, I think it's advisable also to transfer all to digital format, a secure digital format, so you can keep your logging, keep your information in a secure database, but not in paper. Of course, paper is important, but try to pass this to a digital secure format, I would say. And also, you know, the updates, and you should put a qualified person managing or updating your data. Qualified means somebody who knows how to use this database I mentioned, and I call administrator, and keep a backup and internal audits. Why this is important? Because along the life of any deposit, we have a lot of information. If we don't keep organized, and also we don't keep backing up, and somebody who in charge of this data, it can create several things that we don't know, you know, and convert your database in garbage that will not be useful for your estimation. Here there is some examples, yeah, very brief examples of what you should do, you know, in addition the previous tips I mentioned is check the database for errors, so duplicates, overlappings, color, typos, missing constantly. Not only when you are about to update your model. So this is important because the administrator or the people or the geologist or the practitioners need to be, I mean, diligent with this, because it's as a matter of save money, in this case data. And also most geologists know about QAQC, protocols, duplicate blanks, standard, these kind of things also are important to keep update as a standard mine. I mean, follow the guidelines of the standard, the current standard guidelines. It's important because this is gonna guarantee that your data is in good health and the integrity and quality. Okay, passing to the second essential thing. Yeah, I know some people might think, you know, when you gonna start about geostats? Yeah, wait a minute, but I have to think about I have to talk about first from the basics. It's like when you want to build a house, you have to do first the foundation of something, right? In this case, I talk about the foundation, which is database, and also I like to talk about geology. As I mentioned, you know, geology along with data, I mean, the geological knowledge is another essential thing in resource estimation. And also when you're gonna apply geostats in this, because a very good geological understanding of the deposit will be very, very useful for doing your, as I mentioned in the cycle, to do a very reliable geological model, which is the base of all the study. Okay, we talk about, as I mentioned, the explicit way of doing things several years ago, and now we have technology who's helped us with this very nice tool. I mean, nice tool, which is Lifro, and also the software that has an engine called implicit modeling, which is basically an engine on geostatistics that do the implicit modeling for us. But in the wrong hands, this very nice, cool, you know, device or tool can create many things that we are not want to see. That's why one of the principal tips in here, you should have at least the knowledge of the genesis of the deposit. You're gonna be doing one estimation in your deposit, in your project. I'm talking about, you know, geology, including lithology, the basic things at least to do a first and implicit model. And also, one of the things, the key in this slide, I want to emphasize among many things, many words I put, is, you know, I recommend a mixture, I would say, a combination of explicit and implicit model. Why this? Because there is certain things that software cannot do, but the geologists or the people who know the geology will. That's the best approach on any geological modeling base is the combination of both. Implicit tool, but putting something explicit and knowledge to that. This will be, in summary, in the geological terms, that one of the tips you should consider. Don't use just explicit because you're gonna take a lot of time, and use implicit modeling, but add explicit things that now any software will allow you to do these fixes or these adjustments. Okay, this is gonna be, as I mentioned, give you a geological interpretation that is that star, if the star is the skeleton, I would say the estimation. So the statistics in geology is a tool. I would say geostatistics. The statistics in geology means geostatistics. It's going to translate the geological model into numerical. So the exploratory data analysis will be using this model, which means we can perform univariate statistics, which is basically the analysis of geostatistics inside geological features. And also we can do multivariate statistics that geostatisticians like this multivariate one, because we're trying to find the relationship from the main minerals. I would say main, for example, if I'm gonna mine copper or gold deposits, this could be the main elements on the main minerals. But they need to, you need to, as a practitioner or as a resource estimation practitioner, you need to know the relationship between these elements and the other elements that comes with it. Which means, as you can see here in the graph, for example, know the relationship or between those elements will help you to understand better your deposit, and will in the long run will help you probably in your estimation and your prediction, the future prediction. For example, you know there is a relationship between gold and copper, you will know exactly, and also you can impute values in the future using your statistics, missing values of gold using copper by applying multivariate statistics. This is and also a very huge, it's a topic for another talk, but in general terms, the important thing is you need to know this relationship, right? That's the main point this year. But not only the univariate statistics, which is the main element, but also the multivariate statistics. This is basically the two things you have to take into account. Geostatisticians like to analyze a lot these things, but in the practical way, it's not complicated, because nowadays software allow you to do this kind of graphs and allow you to do this kind of relationships and so on. Okay, so we have the geology, right? But some people can assume that geology by themselves are domains. Yeah, so it's depends on the deposit. Sometimes it's true, sometimes it's not true. But because if you really have a very simple deposit that on a specific kind of rock, it's carrying off all the mineralization, it's true, because this specific type of rock will be a domain by itself. However, the majority of deposit, as a geologist I can tell, it's a very, very complex thing, that the mineralization sometimes is no deposit in only one type of lithology. There is a combination of factors, which is that's the reason why I mentioned that it's important for you to know the genesis of the deposit, because you can have a type of rocks, you have alterations, you have mineralizations. Any feature it's related with the deposit, it's important to know for doing or define the domains, which means in geostatistical terms, we used to call stationarity, but some people are not familiar with this thing. They say, okay, the decision of the stationarity. Yeah, some people are familiar. Okay, what you are talking about? But it's, in general terms, the decision of stationarity is the domain definition. So, means by breaking up different features of geology and combining those, you come up as a practitioner with the domains, which is basically the combination of different geological features. It's not only one, remember, but only this was for the majority of them. That's why I emphasize very clearly the term geology, because some people might think that, you know, you're gonna estimate without knowing anything about geology, which is, it's not, I think, a good approach for estimation. That's why it's important, again, take this into account, because the domain definition will practically regionalize your areas of mineralization. What I mean regionalize, this is gonna divide the deposit in reasonable areas, but by using statistics and combining those. With what I mean, for example, in a porphyry deposit, I will localize the potassic alteration, let's say. The potassic alteration, which means has the most of the mineralization, but not all the potassic alteration will have. Some potassic alteration will be barren, and we have to divide this potassic alteration in two areas statistically. I can discuss. We have to use statistics to divide these areas. So, in order to determine representative statistics per domain and combine them. So at the end, the decision of stationarity is yours. I mean, the practitioner. You go and define these domains by combining grades and geology. Remember, grades and geology. That's not geology only or grades only. That might be a very simplistic ways to domain just using grades. You have to use geology also, because it's the correct way of taking the decision of stationarity or defining domains, whatever you want to call. Okay, once you define your domains, sometimes there is a situation, my experience said, that we have few data in one domain, and we have also domains that are very similar. With the similar mean, they are the same kind of related alterations, and also sometimes they can be similar type of rocks. You also need to be analyzing statistically these domains in order to merge, if it's possible, when you have few data. Or it's important to merge similar things, because geostatistics will work better in a number, a reasonable number of samples, but not in few samples, right? You can make, let's say, exaggerating, you cannot make a domain with 10 samples, let's say, you know. So you have to merge with other which has similar statistical values. That's why it's important. Use statistics for this kind of decision, right? The decision of regionalized areas based on geology and numbers. Yeah, remember that tip, it's important. Okay, so once you have your populations, let's say your domains, your group of whatever you want to call, your clusters, yeah. So you have to do analysis. I say you have to, because you're gonna use geostatistical tools for estimation, especially not all, sometimes for no geostatistical tool is important, but especially for ordinary Kriging and other tools, it's important to do a boundary analysis. Why is this important? Because this analysis will help you in the estimation process, not only to refine your domains, but also in the estimation process. It's gonna help you to refine very nice domains. With sometimes if you find hard boundaries, if you don't find the transition, which we call sub boundaries, this will help you to put, I would say, certain parameters when you're gonna estimate a neighbor domains. That's simple as that. You know, you're gonna put, which means that you're gonna probably take some sample from the neighbor to estimate one domain. It's in case it's sub-boundary. in case it's hard boundary, you don't have to take, or you have not to take the samples from the neighbor because it's hard. Otherwise, you're gonna bias your estimations. This is an important concept we have to take into account when you analyze this, because some people will think, I'm doing hard boundary because I'm gonna make only my domain. No, it's not only for domains. It's to use this in the estimation process, right? This is two objective, which is really important. Most people will agree with it. Most people in practice use, and I think it's an important tip you have to take into account. Okay, now you have your domains, you know your deposits, you learn about the analysis of your statistical data. I mean, exploratory data analysis. I'm sorry. Sometimes English and Spanish comes together, and so I cannot as well. So the thing is, once you have the domains, you start the half of the way, because you know that your deposit, you know how is the continuity of, I would say, intuitively, how is your mineralization, what geological features are controlling your mineralization, what geological features are not mineralized. You did a half of the way. So now you have to composite it. I have to bother to composite? How can I use only the samples? Sometimes there are some projects that they are kind of, from the beginning, they use a kind of composite thinking. Yeah, like they sample 2 meters from exploration, 2 meters, 2 meters, 2 meters, and they will never systematically, they will never change these 2 meters. But the majority deposit, it's not that way. Majority of deposits, usually they measure on different, they do contacts based on the geology. We have different, we call geostatistician, we call support, different support sizes, like can be from centimeters to meters, sometimes 2, 4, 6. But if we use this data for estimation, we're gonna increase variability, and sometimes we can bias without noticing. That is important compositing. Compositing is important thing, a basic thing we have to do before we estimate. So it allows us to obtain a representative sample that will eliminate any source of bias, as I mentioned, and bringing only. As you see this one, this is a very common approach for compositing, is doing a histogram with length versus frequency to see what is the most, I would say, popular dimension or size of compositing. Let's pick a number, 2 meters, right? So the general rule, and everyone agree, it's 2 meters should be the size or the length of the composite. This is the general rule. However, some deposit that usually for advanced deposit, not for exploration area, they require the compositing proportional or even the same size or same length at block size, same length at bench. This is especially for very mature projects that it's important to composite the size of the block of the SMU, called the selecting mining unit, and this will allow us to reduce variability and also reduce any kind of bias, conditional bias in estimation, especially when you use geostatistical analysis. So one of this, so another tip, I know many tips. Okay, it's recommended to composing first. Okay, yeah, this comes to the next topic, which is I recommend personally because it's a very controversial topic. If you're gonna composite, okay, after composite, what comes next? Yeah, you have to cap. You know how to cap. Okay, in this case, I put we have to cap. Cap means that we top cutting. Once we have the composite, my experience said that most of my deposits I composite after, I cap after compositing. This is really a controversial topic, but I stick with it because I have several reasons. I say compositing is better after, capping is better after compositing. Okay, but what is top cuts? Top cut is the, the top cuts usually it's the process that you cut the high values, or we call the outlier, right? Yeah, this is very common in every data. You have outliers, you have to cut this one. But there is no theory in resource estimation how you're gonna cut, but we have tools for that. We have tools in geostatistics and statistics, tools that, and even if implemented in the softwares nowadays, as you see here, probably some of you are recognizing this. We have available tools for capping. These tools has the basis of statistics and geostatistics knowledge. I won't explain, I see in detail any of these tools, but I will tell you, but any deposit, every deposit is different. We have the tools. Sometimes we have to combine these tools, but the most, I say, traditional tool we call the resource estimation practitioner is the decile method, which is in my case is in this area. The decile method is this graphic here, which is basically doing a statistical or decile, as I said, and analyze if the 40%, if in the last decile, it's helping you to tell you should cut this one. But it's just warning you. Doesn't mean you have to do this. So remember that you don't follow strictly the rules that it's made. That's just is telling you, you should. But you need to, again, in the practical way, I'm not talking about theory, I'm talking practical tips with the base of theory. You should use probably the log probability, and also you should use a histogram, and also you should use a cumulative methods, and probably you want to use this mean and variance one, which means you're going to control the variability, or the what we call the coefficient of variance. If this coefficient of variance is above 2.5 or 2 sometimes, it's telling you the variability of your population in a specific domain is going to be biased or is going to be variable. So means that outliers will generate this. If you don't cap this, probably you're going to have no good estimation. That's why it's important to analyze. Again, there is no rule for capping. You have to know two things: where these outliers are and what is the impact will generate. A rule of thumb, or a very important advice, I would say, you need to use different approach for capping, the ones I show you, and also do a sensitivity test, which means you're going to cap and use different cappings or different tools, and also do what the estimation look like. Which one is generating the laws of moving, if it is changing dramatically, it's an important thing we need to consider, because some people, they don't want to simply do top cuts because they believe gonna reduce their metals, which is not true, because sometimes can overestimate deposits. And also some people are afraid to cap because of that. But some people want to cap all the time, which is also another extreme that we have to analyze where the outliers are and what they're gonna generate. That's two important things take into account when capping. And also, you probably, if some geostatisticians are attending this talk, probably you might think you're not talking about just that. What? Yeah, there is statistics behind that. There is geostatistics behind these tools, because these softwares comes with something easy to apply, but there is science behind it. There is some things you have to understand. For example, the values here, you have to understand what the coefficient of variance means, why you are reducing the coefficient of variance in this case. That's the important thing to understand what we are doing. Okay, a lot of theory, but the thing is, I'm jumping from one topic to another, which is probably too overwhelming for any one of you, but excuses for that. I'm trying to cover several topics that I believe it's important. You're gonna have probably time to review it and contact me if you have questions. Okay, the clustering, it's also another thing. I won't say it's the most important, but it's something relevant in order for the estimation not be in certain areas overestimated, especially when you use methods which is not ordinary kriging. You need to know this one. And also because at the end, I will show you when you're gonna compare the validation, you will have to compare the clustered data with the estimation, which is, I want to explain why. And that's why it's important to know this graph will show, what is wrong in this sample, in this graph. It's wrong because most of the deposit, we focus sometimes when we drill in the richest part. We focus our drilling, we obtain most of our data in cluster. We cluster our data, and sometimes this data can generate high grades, high values that it's not real. So that is important. We need to decluster before we estimate. This is one very well-known tool that is for using how to select the cell size for one of the methods that for the clustering. But in this point, it's important one thing, as I mentioned, when you use ordinary kriging, remember that you don't need to decluster the data, because ordinary kriging has inside I would say this algorithm has a declustering tool, I think, engine, I would say. Yeah, ordinary kriging declusters on itself by itself, but when you're gonna come with estimation with inverse distance, or even use a sequential Gaussian simulation for any estimation or simulation you're gonna perform, you should decluster your data first. That's a thing you need to, even though sequential Gaussian simulation use as a background, a simple kriging, you need to use you need to decluster your data before that. Now we're gonna have, I would say, one of the core of geostatistics for using the tools, which is spatial continuity, or we also call sometimes measure the spatial continuity using different tools like biography, right? This is important to mention because not all deposits are the same. So one deposit, even in the same kind of deposit, I would say, I would put in the type of deposit, a porphyry deposit is different to another porphyry deposit, I would say in the same country, in the same kind, because both has different spatial continuity of mineralization. They are not the same. So that's why it's important to every time we estimate, assess this spatial continuity. As you can see in the graphs, we have this, I took this from one of my geostat professor. One of these in above is the very random deposit, and usually these kind of deposits are, like, I would say, quaternary deposit, this kind of things is random, and there is medium continuity, there is a long continuity, and also the deposits that show very long and very clear anisotropy. You have to take this into account when you're gonna be doing biography. As you see in the left, you know, I also took this picture from a Snowden estimation cross. You see three populations that looks the same, right? You see only numbers. You see this must be only from only one deposit, right? But it's not true. The deposits are different, I say. If you see a population, doesn't mean anything. You have to analyze the spatial continuity. That's why the beauty of geostat, you combine stats with geology. Okay, but how are you gonna measure spatial continuity? You see very nicely in this unit. On the left, you have the geology and, you know, the interpretation. On the center, you have a we call a biography map, and on the right you have the bio. Yeah, but some people probably don't like to do biography or don't like to model biograms, but it's something essential we need to know. And if you're gonna enter, or you are if you are immersed in the resource estimation, especially if you're gonna use geostatistical tools. Okay, there is a list here. I'm gonna read that. You can read with me. I want to explain also why the biography model is, why to read, what the, yeah, okay, why I have to do biography, in other words. Sorry. Yeah, because it's needed for measuring the variability of one element you are looking for among distances. I mean, you're gonna measure from one point to the another point how they are variable in a certain distance. It's needed. The software or any other technique cannot do by itself. So as I mentioned, by doing or by modeling a bariogram, you kind of integrate the geological part. That's why I mentioned at the beginning, the geology have to be translated in numbers, and the bariogram will help us to do that properly. If you do a good bariogram, you're gonna translate this geology in numbers properly. If you don't do, for sure, you're gonna translate anything else, but not the proper numerical model. And also, as I mentioned, this is a kind of legitimate the distance measure, which is scientists we call positive definite. But some people maybe are not familiar with this term, but it's simply the distance measure, as I mentioned, between two samples in the space. Okay. Okay. Also, the Kriging, as I wanna talk about this, Kriging is I would say the star of the estimation of the geostatistical tools. Use biography. Without biography, it doesn't work. So you don't want to use biography, you use traditional non-geostatistical methods. Okay, and also the variograms give you, or the variography gives you the opportunity to measure, or when you estimate, and also to come up with variogram variance of the deposit. How variances in different areas, or how variances are a specific domain related to the other one. The variance is important in order to use this for uncertainty assessment or risk assessment. That this is another topic, but also because not only using Kriging and also using simulation techniques, uncertainty is important for risk analysis, which is something forgotten but important. That is another thing. Now, this is not the scope of this talk now. Okay, so the variography has two steps, which is the experimental variography and the modeling. So some people can tend to confuse these two things. When you talk about variograms, you talk about two steps. One is doing your experimental and the other is modeling it. This graph is showing how to do your experimental variogram, which simply is generally these points that you see here, generally points in the XY, which X be giving the distance between these pair of samples, and Y giving the variogram, or the difference at the value, I would say, variance between these samples. Probably some of you see this one. This is, I won't explain this because I will take a lot of time. But the main thing in here is how these points I showed you before, how these points in this, how these points in here are formed, how the software is calculated by using this formula, and also I won't derive this. I left this for scientists. So I mean, I used to do that, but the thing is, nowadays the software do this thing. This is just the explanation how the software is taking a cloud of samples at different distance, which means this cloud of samples, let's say taking the above here, it's a kind of it's in the limit of the seal, which means below this point isn't, or above this point is not correlated, which means below this is still correlated. It's going by approaching to the zero value, we are correlated, so which means intuitively it's telling you these points is a cloud of points on the deposit. This is the experimental. This graph is telling many things, you know. And also on the right, you see the calculation, how the formula is applied and how the software do that. But if you're gonna go further, probably you can check this one. It's very comprehensive, and many books like several practitioners like Clayton Dodge, Isabel Clark, all the other experts in this area. They have a practical exercises you can do in order to understand better this thing. But the main the main objective of the variography is to measure this variability using distance. How variable is from one distance to the other. Intuitively, you go farther, you're gonna be less variable. I mean, less correlated, more variable. And this is the main point of variography. That's why it's important the domain step. So you're gonna do, this is by domain, which means you're gonna focus by domain this variography, and you're gonna have a very accurate measure of spatial continuity. You do that. So here is the different kind of, I would say, models that is used for the modeling purpose, for, in other words, for fitting your experimental variography. This is the second part. You do your experimental and you fit your variogram, which is mostly this one you see in the right. It is the directional variography, a 3-dimension, which has the major, the semi, and downhole, which is represented usually as a ellipsoid, and also it has different components that you must know: the seal, the range, and nugget effect, which is generated from these areas. Nugget effect here, the seal, which is the above part where the correlation finish and go up, it's not correlated anymore. Going down is correlated. And the range is the point where you reach until what point it's correlated. So this is important thing to understand, because once you're gonna set your parameters, estimation parameters, you need to know this one. What is the limit on my variography? Why my limit is telling me this thing? How I gonna use in my search parameters, these kind of things. It's important. But most importantly, in the variography process, which is made nowadays with software very quickly and very good basis, as I told you. After this, you're gonna have the basis and reserve by yourself. But the thing is, the most important thing before we do the directional variography is to measure the nuggets, which is mostly the first step of fitting the variogram, which is using the downhole. I would say downhole is going down, or the hole, which is actually the nuggets is the variability between these spaces downhole. You have a drill hole, which is, let's say, 2 meters, and between these spaces 2 meters, there is a kind of, I would say, variability. So with the downhole variography, you measure this variability, which is, in general terms, the nugget effect. With the nugget effect, after that, you can do the other ones. So keep this in mind as a tip, you know, before downhole survey. And also, there is something important, as the majority of deposits are very heterogeneous, are difficult to do variography, I know, but most of the people, that's why they give up to doing good variograms. But there is a kind of advice, I would say, you have to normalize the data in order to decrease this. So transforming this data to the Gaussian space, I would say, it's helped you to deal with this I would say, high and low values, and gonna help you to do better variography, and also you can back transform it and use it in your estimation. This is a very good point. And the other thing is just normalize to transform the seal or the total variance in one. And also another advice you should, in case you don't want to transform the data on Gaussian space, you just normalize to one, which will help you to do your fitting correctly. So I say, practical tips. This is the things I have learned by doing a lot of fitting in my variography. So, and also I taking some advice of people who really have a lot of experience in these things. Along my experience, I talked with several talented and good, knowledgeable practitioners. Okay, so you have a good biography. Okay, you did a kind of, you understand all the things I have explained to you. All of this, you have a very good grasp of this. Let's say you know. But now comes to the moment of truth, which is the estimation by itself. As you see, we went, I would say, 80%. Before that was the other, I mean, before that it was already 80%. The other 20 is coming, which is the estimation process by itself. If you have a good variography, good geological knowledge, you know your deposit, you did a very good estimation domains, this will be very, I would say,
I don't want to use the word easy, but it's going to be more understandable. The thing is doing any kind of estimation, especially geostatistical method estimation, it's going to be manageable, very manageable for you. Okay, but doesn't mean some people can confuse resource estimations only this part. Not, as you notice, I explained all before. All things are the base of this. Okay, you wanna use ordinary Kriging. That's I'm gonna focus in this for the following. It's one of the tips is to use this very, I would say, useful tool called Kriging neighborhood analysis, and also called KNA. That all, as I mentioned, all most of the software nowadays, especially software, the commercial ones has this tool inside. But what this tool is, sometimes some people don't understand what this tool does and why it is important. It's important because Kriging neighborhood analysis make a previous analysis how you Kriging is gonna perform. It's like I would say a kind of validation, previous validation that's telling you if you use these parameters, your estimation will be optimal, something like that, right? But that's why it's important. It's like take this as a tip, you know, try to do analysis, Kriging neighborhood analysis prior to estimation, besides the other things I have explained. Why? Because in this analysis, you're going to use a slope of regression and Kriging efficiency, which is two output variables that giving you the efficiency as a name of the Kriging, and the slope of regression that's measure the smoothness, how smooth, because the smoothness has several consequences of bias or generating conditional bias in a deposit. By having a very good value of slope of regression and Kriging efficiency, you are kind of you're gonna decrease this smoothness in your estimation. So that's why it's important to optimize your parameters using this one. For example, in this case, if your deposit is a new deposit, it's the first estimation of the deposit, you're gonna use the what we call in Kriging analysis is using different block sizes, and you're gonna optimize by slope of regression and Kriging efficiency. Which one is the optimal one you should use in your deposit, right? But as you know, defining the block size deposit on a specific mine has to be, I think, has to be using different things, like how is the method of mining, or how is the distances between samples, these kind of things. Once you know that, you can perform this one and optimize which one is the size, the optimal size. After that, you can also see how it's going to be the minimum and the maximum number of samples or composite you're going to use in your Kriging. After this, you're going to choose how it's going to be your search, or how it's going to be the distances, the optimal distance of your first search in your estimation. Because this Kriging neighborhood analysis use variography, automatically will give you as a starting point the ranges of the variography, and also other values that are close to these ranges that will give you the optimal value for the search. Again, it's an optimal search, right? You can start with your ranges of the variography, but you want to have something optimal, use this tool. And finally, the discretizations configuration, which is also important in case you are dealing with different sizes of block model and different sizes of composites. It's better to know how gonna discretize the best. I mean, it's gonna give you the optimal discretization configuration. As you see in the right, this is actually a summary of the estimation parameters based on the analysis, because this analysis use variography, as I mentioned, and you're gonna come up with different plans of estimation and also all the values you're gonna need for estimation. Again, parameters of estimation besides variography. Okay, so now comes the estimation. This is a simple graph. The domain, I say, you know about that, and you're gonna estimate blocks that using samples. I think ensemble location uses samples. No, right? And you're gonna use Kriging. Most of the time, the ordinary Kriging is the, I would say, also called blue, blue, because this is the base unbiased estimation techniques. It says linear, and what I meant best because it's the same minimum variance. You obtain the minimum error with the ordinary Kriging. That's why it's called the best, right? And also it's linear, as inverse distance, near neighbor, polygonal, or traditional are linear. But the difference of Kriging, as I mentioned, is the capability of measure the variability in space. That it's not a kind of feature of other traditional techniques. Okay, the ordinary Kriging, as again, you know, it's a graph how a point is calculated, or a point of the block is calculated using different values, and also ordinary Kriging use weights for giving weights to a specific direction. Let's say the major direction is giving more weight to the minor or the other directions, because the variography is telling what is the direction, what is the major, what is the minor, and the semi-minor. That's it's important. The ordinary Kriging, as you see, this is the equation, very well known. You know, this is the most important of this equation is measure correlation and also the redundancy between samples, which makes ordinary Kriging, as I mentioned before, it's declustered by itself. The engine declustered by itself. So that's why we don't have to decluster your data before you use ordinary Kriging. That's why I mentioned to you that, because this redundancy and repeatability make the samples, decluster the samples, and also avoid this bias generated with that. This is a plan in Kriging, and most people use it, and some of them use the unique neighborhood, which no use a quarter and octane, and some people like to use, and it's depend on the deposit, as I mentioned. You have a very detailed or a major deposit, or you have a exploration first estimation. You need to consider either use the unique, which is usually when you have the first estimation and you have more data, you can use the mobile neighborhood, which is related with using, I say, samples in every quarter, samples every octanes, these kind of things that make the estimation in Kriging more efficient, but you have enough number of samples. Okay, Kriging properties, I won't tell about that, but it's the only thing is additivity, smoothing, and also unbiased. This is the main things I wanna. This is one. I would say this is an example how the estimation looks like. I see the variability, the varianza, and the real one in the left. The real one, how the Kriging is smooth sometimes, and the variance of Kriging, right? And you see sometimes when you don't have enough data locally, you can smooth a lot And also among, I mean, if you have more data, for sure, the smoothing will be less. And as I mentioned, you know, the smoothness will be controlled by a little bit with this technique. I mentioned the KNA and all the things that you can use it in practice in order to reduce. Yeah, the Kriging is smooth naturally, but you can reduce it by using these things I mentioned before. Okay, so okay, I ran the last part, but the thing is, one of the tips, I don't know, I put it here, it will be, you know, try to use this a kind of due diligent approach, right? Due diligent approach means that document everything from the beginning. I show you the beginning, all the flow work of estimation. Use this approach that documenting and tracking, understanding your deposit from the beginning. So this part of validation will be not a pain in the bottom, I would say, because the validations, even though it's thought that the validation will be at the end, that sometimes it's true, sometimes not, but I recommend to do the validation all ongoing process, validation, even when you transform your raw data into composites, you have to validate if it's the values already make sense, and also validate all the process from geology to classification, right? Use this, again, due diligent approach. Okay, visuals checking, it's a standard one, statistics, swap plots, etc. There is many other tools available for you to validate at the end your estimation, right? You can use, as you see in the graphs here, you have this is a QQ, like you measure the bias of the estimation versus the real. You have visual inspection, you have deriva or swap plot, I call, and you have many other tools like comparing the global means of metals with different techniques. There are plenty of tools you have to validate at the end, besides the validation I mentioned in the ongoing process. This is one example of the visualization. The main thing here, you have to visualize what you see in your biography. You see your biography and your geology, means geology, biography is the translation of geology, and finally, this is the final product. This is a numerical translation of the geology. It means in a specific domain, you should make sure this high grade makes sense with the geology, and also it's something that your biography is giving you, right? But sometimes we don't check it. We can do many things that it's not good for the estimation. So this is the purpose of validation. Validate the samples, but also with the previous geological knowledge. This is examples of the global average comparison. When I say global, means that for every domain, you have to calculate an average of grade, let's say, from the model and from the composite. But if you use ordinary Kriging, you have to compare the mean of a specific domain with the mean of the declusters composite. If you use, let's say, the mean of the cluster deposit, for sure the cluster deposit will, the mean will be greater, and you will see, okay, my estimation is underestimated. That's not true. You have to compare apple and apple, not apple and pear or other fruit. But the thing is, that's kind of important when I talk about the clustering techniques. It's important to decluster your samples, even though you won't use in ordinary Kriging. You're gonna use it for comparison at the end for validation process, or for validation purpose, right? This is the table. Another thing you can compare is the distribution of the validation, of the estimation and the distribution of the composite. and the distribution of the samples, especially composites. As you notice here, in case of the mother one, ordinary Kriging estimate, compared with the left side, it's kind of related, but using indicated Krig, it's more related, you know. That's why I was telling you, even though I focus on ordinary Kriging, you can use another geostatistical technique in order to do your estimation. Every deposit is different. So you have to find a specific tool. I recommend a geostatistical tool to estimate. Geostatistical tool, ordinary Kriging, indicator Kriging, there is local uniform conditioning, there is plenty of tools you can choose in order to do your estimation well. But all of these will follow the guidelines I show you, and also, you know, all the tips I gave you. Okay, this is an example of the also very well-known SWOT plots, where you compare the samples with the blocks and the number of samples you use. And now it's very, I would say, useful, practical way of validating your domains. Yeah, it's a kind of basic, but the minimum requirement for estimation, validation, right? And also, this is a kind of geostatistical validation tool, which is, you know, you want to measure the conditional bias of your estimation every time you iterate a model. So you want to compare, and also even though adjust some parameters by looking, after looking this one, you can adjust some parameters that will make your estimation unbiased, or at least reduce the bias, the conditional, the natural you will have with any method, right? But in the ideal world would be the bias 0, but at least you can reduce as much as you can. So this is the tool you want to use. I recommend to use, and also in case you cannot, let's say you are using ordinary Kriging, you cannot reduce your conditional bias anymore. You have to analyze that. Probably the problem is not of the estimation tool. The problem would be you need more data, closer space data. Probably you need to change your support, like your samples are very small. You might want to increase your composite from 2 to 4 or maybe greater, and maybe you can enlarge the size of your block model. Can be another thing that can reduce the conditional bias. And if you, I think, are done with this and you still have problems with ordinary Kriging, you might consider to use another technique which is available also. One technique I remember in the past I used is localized uniform conditioning, and also multi-indicator Kriging are another things that you can use in order to reduce this conditional bias that usually Kriging has. So you have to evaluate these things. Remember, this is not a recipe for every deposit. Every deposit is different, right? Okay, as a final tips for estimation will be iterate the validation process until the estimation results are not biased, or at least you have a small amount of bias, or the ideal thing is no bias or no conditional, condition bias. And compare the global mean, the ordinary Kriging I mentioned, and also use traditional techniques like inverse distance, near neighbor, polygonal, whatever, to compare your estimation. For sure, the official will be the statisticals. I recommend ordinary Kriging, but the other one will be for comparison. It's like a kind of validate your estimation. And as I mentioned, document in the proper way all the processes, that it's not only for doing final reports, it's also to explain what is happening and to understand what is missing, to understand what you have to do next let's say you have to drill more, let's say you have to improve the sampling process, or you have to, I don't know, change the way you used to organize your data. Many things can help you if you have a very, I would say, due diligence approach of recording information. That's, I would say, one of the final tips I can tell you in terms of estimation. Okay, and briefly I want to talk about, because this is a kind of also another topic that this is not a recipe, it's depending of the person who is doing the estimation, or generally it depends on the QP, we call a competent person that has a lot of knowledge in these things and it can classify. However, this is only a graph, you know, it's the expert assessment related. We can use distance for samples, you can use the density of sampling, you can use geometrical configuration, you can use Kriging variance, even slope of regression, as I mentioned, Kriging efficiency. Many tools you have available when you perform your statistical method to classify. You have to combine this plus experience and deposits and also reliability, accuracy. Many things comes in this area of resource classification. However, I have a couple of samples that I did, I think recommend when you use especially ordinary Kriging, use the slope of regression and Kriging efficiency is a good way to classify or your resources. These values are in a specific deposit, but as I told you, that this is not a recipe. You can adjust these values and see and compare. If the deposit is a kind of mature, you have other tools like reconciliation, you have blast hole, many things you can compare in order to classify your resources. But if you have explorationist or exploration project, probably this is going to be helpful to start with something, right? And this is a kind of a start, right? Okay, another tool also you can use for classification is reading in many books, and also some, I took this from Snowden. And also I use sometimes for some deposits, use the variography for, especially the ranges, for classifying. As an example here, for example, the 2/3 of the seal, and the search range, it can be classified as a measure, but as I mentioned, you can combine this on other things. But this is the case that you have a very nice variography that most of the time it's not real, but you have a very nice variography and you can use it. You use it for exploration deposits. It's a good tool, also variography for classification. Okay, to finish my long presentation, I'm gonna conclude with certain things. One of the things is these talks really, as I mentioned at the beginning, highlights general practical tips based on my knowledge and experience. And I know probably most of you have also other experiences that maybe you share in the future talks, and also I kind of try to explain in simple words these things. I didn't want to, you know, confuse you more, because I put a lot of information, but also I want to say, using geostatistics, I mean, I'm not saying the traditional way of doing things were wrong, but I'm telling you that geostatistics is a very wonderful tool that can help you to reach at least the minimum standard of public reporting for mineral exploration, and even better, right? Because it's auditable, it's reliable. If you do well, it has all the characteristics that regulators or people are looking for in an estimation. And so these geostatistical techniques will provide these tools, right? I know geostatistics is a field is growing, or many people are doing research. You can use not only mineral exploration or in the mining industry, and also you're using all environment, different fields. But in mining, you know, you can take advantage of these things by as my last tip would say, I would say, you know, yeah, don't stop learning. Just keep learning. Take any opportunity you have for learning. Taking very nice classes that's around there. For example, one of these nice classes, I would say practical. I would say practical statistics from Isabel Clark, and Clayton Dodge has also very nice practical geostatistics courses, and also other ones that are over there. So if you are a beginner in this area, I think this is gonna be a good start to review this information I'm gonna share with you guys, and also search. There are plenty of information out there, and also try to learn as much as you can. This will be my last tip to finish. And I use information of these people, as you say, Clayton, Mikkel, yeah, all these people that I met, I work with, and you know, it's like it's important for you to review information of those people that now probably I meet some of them. Excuses if but I just use information from them. So. But there are many people that are very knowledgeable in this area. Okay, thank you.
Okay.
It's not too quick.
Efrain, thank you very much. This has been a very, very good presentation, and is bringing a lot of value to the mining match community. It really is a good summary, and anyone who wants to start doing resource estimation can watch this video and learn the basics, right? And like you say, you have to experiment, do practice, hands-on, and keep learning, and so you will become a resource geologist, what it's called. Anyone who would like to have a question for Efrain, please raise your hand, or just go ahead and unmute yourself. I'm going to allow you to do so now. And although someone wrote a question, but I prefer to give a chance to someone to just talk, and it's better to participate. Well, in the meantime, I will read the question from Reza. He said, if there's a minimum data requirement to do geostatistics. And the second part of the question is, what is the optimal distance between samples? What would you say to that, Efrain?
Yeah, I think I'm gonna answer with a general answer.
Yes.
Yeah,
because it's very specific
like
to every deposit.
Yeah, exactly. Yeah, especially the optimal distance is depend of the type of deposit, depend of you know, it's depend of even the type of samples you get, and also if we want to talk about the minimum number of samples to do geostatistics.
Yeah.
As a common sense, you know, you won't be able to do any geostatistics, especially variography, let's say with 20 samples, right? Maybe 100 samples would be the minimum to do a variography, at least. But again, it's general thing. It's depend on the deposit, depend on the, but try to avoid lower than 100, let's say, because your variography won't tell you anything. It's better to merge. If you want to merge domains, just merge them and do a variography with them. You know, merge, and you can use it. Similar domains, you can use it. But usually this problem comes with exploration deposits where you don't have enough data. right? In this case, it's worth it to merge domains, do less domains than when you're gonna have a mature deposit, like, right? It's common sense. I say, okay, Geostat doesn't replace the common sense. Common sense for doing that.
And I will add that also the geometry of these samples in the space is important. Like,
yeah, exactly.
They are too distant apart, and that's part of the second questions. They should be within reasonable distance, right?
Yeah, exactly.
And depending on the geology.
Yeah.
Okay, anyone else would like to have a question? Please go ahead now. I think everybody's tired because they have been here 1 hour.
Yeah, I know. Probably they understood everything, or they don't understand it. But either one, it's like, at least I tried to share something.
Yeah, it was very good, very good. I think it's very comprehensive and detailed. So if there's no more questions, there's Reza. Go ahead, Reza. You raise your hand. Oh, lower the hand again. Oh, he was clapping. Okay.
Yeah.
Okay, I think if no one, you have a last chance now. If no one has.
Can you hear me? Sorry.
Oh, go ahead, please.
Sorry.
Can you say your name and where you're calling from?
Yeah, I'm Reza. I just tried to reach you, but I think I have a problem with my mute and unmute button.
Okay.
It sometimes goes weird. Thanks. A question. Do you have any experience in oil and gas? In fact, geostatic model building?
Yeah, oil and gas, I just did theoretical models using simulation. We don't use it ordinary Kriging, but I have no experience in the practical, I would say, in practice. I just kind of run models with oil and gas using sequential Gaussian simulation, that's kind of things, but more than that, not.
Yeah, the question for me is, usually when I'm using Kriging, I end up with, basically we have limited wells in oil and gas, so we need to do a sort of estimation.
Yeah, sure.
And this is a very critical, because I'm ending up always with bull eyes by using Kriging. So I have to use the sequential Gaussian simulation basically to get a geologically shapely, in fact, distribution. And usually simulation is just one, each simulation result is just one close to reality answer. It's basically,
exactly.
So how do we, in fact, tackle this question or this problem? How do you consider, how do you use this simulation method to come up with one model at the end? What is your suggestion?
Yeah, sure. This is another topic. It's another topic for another topic. Okay. Cost more. Yeah, just kidding. Yeah, the thing is, sequential simulation, I think I would say we didn't explode, or we didn't took advantage of the power of sequential Gaussian simulation yet. But I know in the oil industry they do, like when you use, let's say, 100 realizations, you can average these, and you're gonna come up with the estimation average of these realizations that gonna look like ordinary Kriging or Kriging. This is gonna be the estimate, right? But you have 100 models that you can use it to assess uncertainty and manage the risk that in oil usually has. It's in oil. It's very common to use. I would say some of my previous friends, they use these tools in order to come up with different techniques to do estimation and assess risk in the oil company. But I have no experience in oil, but I know that it's important. Besides the piece 80, PIF 85, you can choose but use all the realization all the time, let's say, all the realization to manage the risk in the oil industry, because the oil is different kind of,
Yeah, I understand it. Well, however, if you, for example, average those simulations, usually you end up with the distribution of the data will shift to an average.
Yeah, exactly. It's
value.
the
So
average.
basically we are distorting the initial distribution of the data, like a sort of.
Not necessarily, but because it's how you're gonna use your, you have a hundred of
True.
valid models in the simulation, right? You can use even the 80, 85, whatever you're gonna choose.
Sure.
But the thing is, there is a lot of research in this using Gaussian simulation in oil. Maybe I can contact you some of the experts. I know some people, they work years in oil.
Okay.
They can have a better answer for you on what you're looking for. But the thing I can tell you, sequential Gaussian simulation techniques are very powerful. You can use now in mining planning. Nowadays, people are using that, but we didn't see in mining industry all the potential it has. But the thing is, it's a very nice question. I will probably by myself gonna have to learn about this thing.
Yeah, basically, for example, if you want to drill a well, you are looking for a deterministic approach.
Yeah,
However,
exactly.
Yeah, so you know exactly where to drill your well. This is very important. It's about millions of dollars.
Yeah.
But in Gaussian simulation, usually you get just a sort of, randomly shape of the things which are geostatistically valid in terms of probability, but you may not necessarily follow the real shape, basically. If I say,
but remember when you Krig or when you average is the same. When you Krig average, you are smoothing the value of something, and but one simulation is also a valid model. It's a valid model that the difference between simulation and deterministic, you call deterministic, the ordinary Kriging, deterministic and a stochastic one. That's why, now oil professional, they find many ways to use these simulations to do many things, because remember, oil also is a kind of, it's not a static model, it's a kind of dynamic modeling where the resources are moving constantly. You need to do a simulation for doing that. There is plenty in simulation, there is many branches, pluri-Gaussian simulation, many branches that you can use it in order to do this thing. It's another topic we can talk in other opportunity, but
sure.
Okay, it's a good one.
Thank you. I would appreciate if you make establish a link to those people you mentioned.
Yeah, exactly. Yeah, you send me a message. You give me your specific question, why do you want to solve? I will contact those experts, because I know some people in the oil industry, they're using geostats and can help you.
Sure.
Okay.
Thank you. Thank you very much.
Yeah,
Thank you, Reza. Thank you for participating.
Thank you.
Everyone that is in the Mining Match app, you can contact directly the people who attended to this webinar. So, okay. I think we have been here for almost 2 hours. So if there's no more questions,
$2. Wow.
we will call it for finishing this webinar. So you have your last chance right now. A few seconds. Okay, no more questions. I want to thank you, Efrain, for sharing this awesome presentation, and this will be available for everyone to watch later, and it will be posted. So please share about the Mining Match to everyone in the mining industry, and you're welcome to share your own experience in any other field that you have. So Thank you very much, everyone, and I'll see you next time.